We are on the sections 3.4 and 3.5, page 28. We are going to talk about inequalities and midpoints. So for your chapter 3, mainly we are talking about the number line, the friend of the reference. Okay, for your x, what we are working on, right? So we are talking about the points, plot the points and distance. Now we are going to talk about inequalities. Then what kind of symbols we are going to use on the number line for the inequalities. Okay, so on your page 28 for inequality, look on the top. Inequalities come up frequently in stats, and it is often helpful to plot the inequality on the number line in order to visualize the inequalities. Okay, so inequality we have what? This symbol and this symbol, less than or equal to, greater than, or this one is greater than or equal to. Okay, we use these four symbols for the inequalities. And less than can be what? Sometimes we say smaller than, lower than, or younger than, right? Less than or equal to, sometimes we use for what? At the most. So when you see this word in English, you translate to math language, you use this, less than or equal to, means at the most, or no more than, or not to exceed. Then this one is greater than, larger than, higher than, bigger than, older than, more than, right? You use this. And this one, greater than or equal to, you need to use at least. At least is no less than, more than, or equal to. Okay, so first you have to connect the symbols, math language, to your English. Okay, that's what they are equivalent to. Okay, so then let's talk about symbols and notations on math to represent the idea. Okay, so when we do say x bigger than or equal to 7, if we do it, graph it on the number line, how do they look alike? So x greater than or equal to, if x equals 7, it's very simple, just a point, 7, right? Greater than or equal to, it may be what? Can be 8, can be 9, can be 10, or 7.1, 7.2, 7.3, or 7.01, 7.02, right? Bunch of them. You cannot just show one number, x equals 7, to show it. It's a bunch of them, many of them. How do you do it? You can only show it by graphing, okay? By graphing. That's what we need to do, okay? So how do we do it? We use a number line, right? That's your 7. Anything bigger than 7. So bigger than 7, right? And include. You have equal sign, include. So you use a bracket. Okay? To where? Forever. Right? Infinite. Right? So when you graph it, you just graph like this. But if you write it in notation, we call them interval notations. You need to do it this way. From 7 to where? Infinity. So you use bracket, means inclusive. For you always write what? Smaller number on the left-hand side, then larger number to the right hand side. Okay? Then you will have parentheses or bracket. Then let's see how we are going to use that. If you have x bigger than 7, then what do we do? Bigger than 7, right? Not including 7. So what do? Not including 7, you use a parenthesis instead of bracket. So that's the portion. Then if you write it in interval notation, you do 7 to infinity. Okay? If you have less than 7 or less than equal to 7, what do we do? That's a 7. Less than, you go to the left, right? Not including 7, you use a parenthesis. Then to where? Forever. But this side is negative, so it's a negative infinity. But you write a smaller number on the left-hand side, so it's negative infinity, all right, up to 7, not including 7. You do that, right? So those are your graphing to show the concept of the variable and or with the interval notation. If it's less than or equal to, so it's here, right? But including 7, so we do negative infinity to 7 inclusive. Okay? Infinity, you always use a parenthesis. So usually we put a variable on the left-hand side of a number that you use the symbols of inequalities. Okay, so if you have this one, 7 less than or equals, so x is a bigger than, right? 7 less than, you change it to x less than or equal to 7, less than or equal to 7. Let me see, x is bigger than, right? You changed. 7 less than or equal to 7, x means 7 less than or equal to x means what? X is bigger than or equal to 7. Okay, so that would be this one. So usually you will write the variable on the left-hand side, write the number on the right-hand side. And if you use interval notation or graphs, you do it that way. Okay, that's how we use the symbol. And if just one variable compare with another number, if we use this one, we call it compound inequality. Okay, compound inequalities. So you have what? Not one inequality symbol, right? Like here, you only have one inequality symbol. All right. So compound inequalities means what? Or you will see on your homework, you call it trilinear. Tri means what? 3, right? Trilinear inequality. Compound inequality means what? You compound them, you have two inequality symbols. Okay, let's see what do they mean. Okay, so if we write it this way, x is greater than or equal to -6 or less than or equal to -2. Means you have some people use trilinear inequality. Trilinear. We just do trilinear inequality. Okay, so means what? You have 3 things there, then x in the middle. Okay, so what do we need to do if we graph it? How do they look like on the number line? So it's between -6 and 2, right? And x is in between, so you highlight here, right? Inclusive, the end point, you have equal sign. so you use bracket, all right? Or on your homework, you might use this way, solid dot, okay? So, but when you write inequality interval notation, you do this, bracket to 2, okay, inclusive. Sometimes we use bracket to graph it, but for stats, we just include those points, we use solid dot, okay? Next one, if 0 bigger than x bigger than -3, usually we write a smaller number on the left-hand side, bigger number on the right-hand side. So we write -3 less than x, 0 is in between -3 and 0. Because on the number line, smaller number always on the left-hand side. Okay? Then if we graph it, that will be things in the middle. Okay? Then we don't include those points. We use this way. Then if you use interval notation, you use what? -3 to 0 with parentheses. Then in stats, right? -3 and 0, those points we talked about in between, right? Not including the end point. We use what? Instead of use a solid, we use hollow circle. It means what? Including everything in between, but not those 2 points. You can graph either way. Okay? For stats, usually we use solid point and hollow circle. We don't use parentheses and bracket. But the parentheses and bracket corresponding to what? Exactly what's on the graph. Okay, next one, it says x. This is a more formal way to show x. What are x's we use? So you do x, then you put a bar there, describe it. You say x is any real number. Then you use a curly bracket to include them. This is a formal way of show x. If we graph it, means this is a line. Where is your x? Everywhere, right? The whole thing. So if you use the interval notation, means what? To the negative infinity, to the right infinity, right? Okay? If you use interval notation, means negative infinity to infinity, then you use parentheses. Or in algebra or math, usually we use this one, like Greek R. Real number, you double strike. Okay, so we also do that. Okay, next one. Graph the inequality 3 less than x less than or equal to 5. Then how do we show it? Okay, so you do your line, number line, your 3 and 5. So it includes everything in between, right? But not 3. So you hollow it, then include 5, you solid 5. So if you show in interval notation, how should you show it? That's a 3 non-inclusive, 5 inclusive, then everything in between. That's the interval notation. Okay, one is with graph, with endpoint solid or hollow circle, or interval notation, or formally with math statement, you will describe x. Then what is your x? X is between greater than 3, less than or equal to 5. Or formally, you use the set symbol we call curly bracket to show the x. Then description will be behind the bar. Okay, That's how we show the inequalities on the number line. Okay? Let's look at the next page, your page 29. On the top, example 2. In statistics, we often want to find the probabilities of an event being at least as large or no more than a given value. At least so much and no more than a given value. Okay? It helps to first plot the interval on a number line. Suppose you want to find the probability that you will have to wait in line for at least 4 minutes. Sketch this inequality on a number line. So we want to sketch what? At least 4 minutes. So at least 4 minutes means what? 4 minutes and above. So it's here, right? You have to decide, do you include 4 or not? At least, what do you think? If you look at your previous page, at least means what? 4 minutes or more. So at least you have to translate to greater than or equal to. So does that include 4? Yes. So you need to include the 4. Okay? If so, the number line is your reference thing. So that's your x. That would be what? Wait in line in minutes for something. That's what we are working on, right? That's your frame of reference. So you mark them, you visualize them. Then if we write in interval notation, how does it look like? Inclusive, 4 to infinity, right? If you write it formal way with curly bracket, that's your x. X is what? Bigger than or equal to 4. And you use curly bracket, a set symbol to do that. Are we okay? Pretty straightforward, right? Look at next one. Another main topic that comes up in statistics is confidence interval. Here we go again, confidence intervals. For example, in recent poll to see the percent of Americans who think that Congress is doing a good job, found that a 95% confidence interval had lower bound of 0.18 and the upper bound of 0.24. So this will be written to this way. So upper bound and lower bound sketches this interval. So what do you think? Pretty straightforward, right? Are they included for the endpoint? So it's in between, include because it is bracket, so include, right? So that's your x. What are we talking about for x? You have to know what you are working on, right? So the things 0.18, 0.24 means what? Percentage of American. That's what we are talking about, right? Who think that Congress is doing a good job. It's about 18% to 24% of people think Congress is doing a good job. Okay? Then that's a frame of reference we are talking about, we are going to study on, right? If we show it, so that's your interval notation. And formally, that's your x. Then x is what? Between 0.18 and 0.24. Okay, so we are learning the symbols, interval notations, and number line to visualize the things we are working on. That will be your x. All right. Next one. Often in statistics, we deal with discrete variable. Most of the time, this will mean that only whole number values can occur. For example, you want to find out the probability that a college student is taking at most 3 classes. So, like something called discrete variables, you don't understand what do they mean. Discrete means separate, okay? So separate the variable and look at that. Why we are talking about those numbers are discrete, okay? Variables means your x, right? For example, you want to find out the probability that a college student is taking at most 3 classes. So we are talking about the classes, that's x, right? Is what? The classes taken. So the student can take a what? 0 class, or 1, or 2, or 3, or 4, or 5, or 6, right? But they are not the 0.1, 0.2, 1. It's not like everything in between. So they are separate numbers, the whole number, right? So we are talking about it wants you to mark what? The student take at the most, okay, 3 classes. That means, what does at the most mean? Okay, at least means from there on, right? At the most means what? Up to. So can be 0 class, 1 class, 2 classes, or 3 classes. So you will mark as such. Then, how do you show? It's not interval notation anymore. Interval notations means what? Everything in between. But we cannot mark 0 to 3, not everything in between. It's discrete, separate only those numbers. That means what? You can have 0, 1, 2, and 3. If it's a discrete, what do? You use your curly bracket, basket to put it in there. So that's your set symbol, right? Or you can do this way. You say, that's my x. What's my x? Describe it. X can be what? 0, 1, 2, or 3. That's how you will show it in a set symbol, we call it, with curly bracket. That's how we do it. All right. Okay, very straightforward. And think about what we are learning, right? So we are learning what? Inequalities with interval notations, with graphs, with the curly bracket set symbol. Okay, then we use the inequalities at least greater than or equal to, at the most less than or equal to, right? Less than or equal to 3. So that would be 0, 1, 2, 3. You cannot have a negative number for taking how many classes. So we don't do that. So from 0 up to 3. Okay? Then let's see how we are going to use. We described how do they look like. Okay? Then we want to use it. In what way? Okay? Let's look some examples on your page 29. second part, okay, use of the inequalities. It says, inequalities are an essential component of statistics. One very important use of inequalities is when we have found a mean or proportion from a sample and wanted to write out an inequality that gives where the population mean or proportion is likely to lie. Another application is in probability, where we wanted to find the probability of a value being more than a number, less than a number, or between two numbers. So we are going to use the inequalities to present ideas for the things we are working with, the X. Okay, so let's see. First one, you wanted to find the probability that a patient will take at least 3 hours to wake up after surgery. Write an inequality for this situation. So the variable X we are working with is what? To wake up after the surgery, the time, right, to wake up after surgery. That's what we are working with, right? Then you would take at least 3 hours. What do you think? At least is your English, right? 3 hours, 4 hours, 5 hours, or maybe 3.1, 3.2, right? So it's at least means what? More than or what? Equal to. So if you write the variable, how should you write the inequality? You should say X is what? Bigger than or equal to 3. Okay? If you write in the interval notation, would be what? 3 to infinity. Hopefully not infinity. That person will be into the coma, right? But possible. So that's the what? The time to wake up after the surgery. We show it in math this way. Second one, suppose you wanted to find the probability that a relationship will last more than 1 week and at the most 8 weeks. Write an inequality for this situation. So what kind of subject we are talking about, what kind of things we are working with, that's your X, right? Is what? The probability that a relationship will last. Okay, so it's saying how long does a relationship last? That's what we are talking about, right? What kind of chance it happens? 2 hours, 3 hours? Oh, not 2 hours, 3 hours. A week or 2, right? Or 8 weeks. More than a week. So you have what? More than a week. More than is what? Greater than, right? So more than a week is what? X bigger than 1, right? Then more than a week and at the most 8 weeks. Then at the most means what? Up to, right? So you do what? Up to 8 weeks. Most up to 8. Then you put it together as trilinear inequality. Okay, how do you show? The X is in between, bigger than 1 and less than equal to 8. So you will describe your x inequalities this way. Okay? All right. And that's how we use the inequalities with the x to show the idea, right? Let's look at the next one. On your page 30, we are going to talk about midpoint and inequalities. Sometimes we use the midpoint as well. Okay, so on your page 30, look at the top. It says, there are two ways of thinking about an interval. The first is that x is greater than the lower bound and less than the upper bound, right? The second is that the center or midpoint of the interval is a given value and the interval goes no more than a certain distance from that value. In statistics, this is important when we look at confidence intervals. Both ways of presenting the interval are commonly used, so we need to be able to go from one way to the other. Let's see what does that mean. Okay, let's look at some examples so that will help you. First one. A researcher observed 45 startup companies to find a 95% confidence interval for the population mean amount of time it takes to make a profit. The sample mean was 14 months and the margin of error was plus or minus 8 months. In symbols, the confidence interval can be written as 14 plus minus 8. We express this as a trilinear inequality. Let's see what they want us to do. So it says, okay, somebody observed the startup company, then feel pretty confident, not like 100% confident, but 95% confident. Okay, you will end up what? The sample mean. Mean is the average, right? They collect the 45 samples from those companies. It will take them what? 14 months to start up a company research. Let me see. Oh, to make a profit. Take 14 months average to make a profit. More or less plus and minus 8 months. Means what? Take 14 months to make a profit. Maybe 8 months more, maybe 8 months less. If 8 months more, that would be what? Take 22 months to make a profit. If 8 months less, some of them 14 minus 8 is what? 6 months to make a profit. That's what he's saying. Okay? So average is what? It's talking about sample mean. Talk about 45 companies as your samples. Okay? Mean means what? Average. You average them out. Okay? For 45 companies, it would be what? 14 months to make a profit. But not everybody 14 months to make a profit. They say plus minus 8 means what? Maybe 8 months more, right? Then that will be 22 months. Maybe 8 months less, that will be what? 6 months, right? It's in between here, okay? So the things we are working with is what? Your x. That's your number line. Then x means what? From 6 to 22, right? So then your 14 mean is what? Your midpoint, right? That's upper bound, that's lower bound. And a month, we call it what? Margin of error. Okay, so means more or less. A month more, a month less. Then what's your x? X, you need to pay attention to your x. That's what you are working with, right? So it's amount of time to make profit. That's what we are talking about. Okay, it's like this one, it's the time to wake up after surgery. This one is what? How long does a relationship last? It's totally different subject, right? So you need to know what you are working with and what you need to do. Then it says, express this as a trilinear inequality. What is trilinear inequality? We did is what? X put it in the middle, compound inequality. You have less than or two numbers here, or you have less than or equal some kind of number here, right? Three parts, tri-inequality. We want you to show this thing in tri-inequality, trilinear inequality, right? So with this style, what do you need to know to do to show this interval? So x is what? In between 6 and 22, right? Then we also include those 2 points, so you use less than or equal to. So that's how you show it in trilinear inequality. If you show it in an interval notation, that would be what? From 6 to 22. That's how you do it. Okay? So we use the midpoint. If we know the midpoint, then from the margin of error, so you can find the upper bound and lower bound. Then you put x in such a way as trilinear inequality or with an interval notation. Okay? Look at next one. A researcher interviewed 1,000 Americans to ask them if they thought abortion should be against the law. The following 95% confidence interval was given for the population proportion of all Americans who are against abortion. Is 0.41 to 0.47, okay? Find the midpoint and the margin of error. Then this is to write the interval in such a form, a plus minus b, like here. Okay, now before we give you this 14 plus minus a, you translate them to a trilinear inequality and interval notation. Now we give you an interval notation, then you want to change to what? Those form midpoint and inequality. Okay, a plus minus b. So in here, it means what? The a should be your what? Midpoint. Your b should be what? Your margin of error. Right? Then how do you find your midpoint? So you have 0.41 here, 0.47 here. What's in the middle? Average, right? Middle is your average in between these 2 points. So what do? So your A is your midpoint. So you should do what? 0.41 plus 0.47 divided by 2, which should be 0.44, right? If this is a 0.44, how much from 0.44 to 0.47? So your B should be the difference, right? 0.47 times 0.4, so it should be 0.03. So then here will be another 0.3. So, or you can do what? 0.44 minus 0.41. You should still get a 0.03, right? So you have to find the midpoint. So you write A plus minus B. So that would be A is your midpoint, which is what? 0.44, right? Then plus minus your margin of error is what? 0.03. So you should write it this way. If you write it in A plus minus B style instead of interval, you should be able to translate the interval notation to midpoint and with margin of error. If you are given with margin of error and midpoint, you should find the range of the things you are dealing with in a trinomial, trilinear inequality style, or an interval notation style. Okay, you can write it either way. We call them midpoints and inequalities. So that's how we specify our frame of reference. Okay, then like this one, what's your x? For this x is what? Is 1,000 Americans to ask them if they thought abortion should be legal against the law. Okay, so the following x for this one confidence interval was given for the population proportion is what? Portion of the people population. All right, who are against abortion. That's what we are talking about, percentage portion of the people against abortion, like 41% to 47%. That's what we are talking about. You can show it by interval notation, means in between those percentage of American, they think they are against abortion. Okay, or we can show them with midpoint more or less plus minus margin of error. That's the study we are going to do, and for our x. Okay, are we good? Okay, so this will be your section 3.4 and 3.5.